Lesson 23, solving two-step equations. Here we are in our new concepts, taking and learning from what we've already tried to tackle with one-step equations and using inverse operations to now breaking it down into two sets of operations and using that same strategy, inverse operations, and then applying those operations to both sides of the equation. In our new concept, it's explained like this. If an equation has two operations, use inverse operations and work backwards to undo each operation one at a time. To reverse the order of operations, first add or subtract, then multiply and divide. Now, normally students sometimes get this confused when they say, well, Mr. Shane, we learned the order of operations. Please excuse my dear Aunt Sally, parentheses first, then exponents, multiplication, division, addition, subtraction. And now we're supposed to do it backwards. Why would we all of a sudden do it backwards? Well, in this case, when you're solving two-step equations, you want to actually do the simplest form of operation first. That way you can simplify that part of the expression and then do the next set of operations in that sequence. Now, we'll see as we practice more and more why that is the way we want to solve it, because it tends to be the best way to go about finding that correct answer. So we're going to add, subtract first, then multiply and divide, or do the opposite of those operations. Take a look at example 1 here. It says evaluate the expression and solve the equation. You've got 3x minus 2 for x equals 4. Here you're going to take and evaluate, which means plug in that value. So the 4 goes in for the x and turns into this equation, 3 times 4 minus 2. Well, 3 times 4 is multiplied first in our order of operations. You get 12. 12 minus 2 is 10. In letter B, it says solve 3x minus 2 equals 10. This time, reverse the order of operations. Here, you have 3x minus 2, so the two operations, you have 3 times x and then minus 2. The easiest of those would be to add or subtract, and the opposite of minus 2 is to add 2. So it says plus 2 to this side. What you do to one side, you do to the other side, plus 2 to this side. If you add 2 to subtract 2 here, this is going to cancel out, and then 10 plus 2 on this side is 12. So you get a new equation of 3x equals 12. Now, because you've added or subtracted first, you're going to go to multiply and divide. Here you've got 3 times x. The inverse of that is divide, so 3 divided by 3. That's going to cancel out, and you get x by itself. On the other side, 12 divided by 3 is 4. So you get to solve this equation by using your reverse order of operations. Guess what? That answer was exactly what we saw here in this example. Example 2 says solve a two-step equation with positive coefficients. So if those items are positive, you're going to first take a look at the two operations and do the simplest operation first. Here, 4x plus 5 equals 17. You've got plus 5. The opposite of plus 5 is minus 5. So you do subtract 5 on both sides. What you do on one side, you do to the other. This would cancel out here. And then you'd have 17 minus 5 is 12. Now you're going to divide by 4 because it's 4 times x. The inverse of multiplying by 4 is dividing by 4. 4x divided by 4 will cancel out and you get x by itself. What you do to one side, you do to the other. 12 divided by 4 is 3. Now, to check your work, you take this value of 3, plug it back into the original equation. So here they go, 4 times 3 is 12 plus 5 is 17. That turns out to be the answer from the original equation, so it's done correctly. Now, what's different when you're solving a two-step equation with a negative coefficient? In example 3, you've got a negative value here for negative 5m. 8 equals negative 5m plus 6. Here to solve, you're going to isolate m, means get m by itself by doing the opposite operations, again, in that reverse order. So it says plus 6, you're going to minus 6. Our subtraction property quality says if you subtract on one side, you subtract on the other. These two would cancel, so you have 8 minus 6 over here, which gives you 2. Now, bring the negative 5m down. You've got this new equation right here, 2 equals negative 5m. Now you're going to use your division property of equality because you've got 5 times m, or negative 5 times m. The opposite of multiplying by negative 5 would be divided by negative 5. So you divide by negative 5 on one side, divide by negative 5 on the other side, and you have your new simplification. These two are going to cancel each other out, and now you have 2 divided by negative 5, which is negative 2/5 as it's simplified, and that is your answer. Now when you're dividing or multiplying by negatives, you're going to keep that negative value with the actual number itself. So here it said negative 5 times m. You divided by negative 5 because there was a negative 5 that was being multiplied in the first place. So with positive values, you're going to multiply and divide by positive values. With negative values, you're going to multiply and divide by negative values in that second step of the two-step equation. If you plug that negative 2/5 back in, multiply by 5, add 6, you actually get it to check out to be the correct answer of 8 equals 8. In example 4, it asks you to solve two-step equations with fractions. Now, to solve the equation with fractions, you might need to multiply by a reciprocal instead of divide by a fraction. Let's take a look at the example here. 1/2 n minus 1/3 equals 3/4. To isolate n, that means get the variable by itself, we do the opposite operations in that reverse order. First eliminate the 1/3, then eliminate the 1/2. To eliminate the 1/3, it says plus or minus 1/3, you would add 1/3. What you do to one side, you do to the other side, so plus 1/3 on this side cancels that out, plus 1/3 on the other side. Now to add 3/4 and 1/3, you've got to have a common denominator. In this case, it's going to be 12. You add those numbers together, you get 8/12 plus 4/12, 4/12 and 8/12, and you get a total of 13/12. Sorry, 9/12 and 4/12. You get a total of 13/12. Now, to get rid of the 1/2, you would say, well, this is 1/2 times n, and that's multiplication. But in case of it being a fraction, instead of dividing by a fraction, you multiply by the reciprocal. So the opposite or the reciprocal of 1/2 is 2/1. So you see right here, they multiply 2/1 times 1/2. That's going to cancel these out and leave n all by itself. If you multiply by 2 on one side, you multiply by 2 on the other side, and then multiply numerator by numerator, denominator by denominator, or cancel where you can. Here you can cancel the 12 and the 2. 12 turns into a 6, 2 turns into a 1. You get 13 times 1, and 6 times 1 is 13/6 as our simplified answer. In example 5, it puts it into a word problem form in which you're solving a two-step equation. You have to take the word problem, read it out, and turn that into the expression. So here's the solution. It says write the expression to represent the total cost at the first gym. So here it gives you what would be a monthly cost and then a fee. So you've got a fee of $90 and a monthly cost of $30 times the number of months that you have with an overall cost. How much would it take to get to $1,500? How many months would it take to get to that value? So from the word problem itself, you write out the equation that looks like this. 30x plus 90 equals 1,500. Here's our two-step equation. Do the reverse order of operations. So it says plus 90, subtract 90. Subtract 90 from 1,500 because you do that to both sides. You get 1,410 equals 30x. You're going to divide by 30 to get rid of 30, so x is by itself. 30 divided by 30 is going to cancel as 1. 1,410 divided by 30 equals 47, so it takes 47 months, which is about 4 years, to get a total charge of $1,500 for your gym membership. Now, let's take a look at our lesson practice. I'll do letter A and B here with you and then show you the rest on the board. Letter A says, justify. Which step would you use to first evaluate 9y plus 6 for y equals 2? Well, if you were evaluating, that means you take the 2 and you plug it in, so you've got 9 times y plus 6. The normal operation tells us that we're going to multiply 9 times 2. 9 times 2 is 18, plus 6 would give us a total of 24. So in the order of operations, normally you would multiply by 2. But now in the next portion, in letter B, it says, which step would you use first to solve 9y plus 6 equals 24? You've got to think, well, I know my order of operations. What's the opposite of that order of operations when I'm solving a two-step equation? So you've got 9y plus 6 equals 24. You don't know what y equals in this case. You're going to do the subtraction portion first because that's the first step that comes when you're working a two-step equation, working in that reverse order. So minus 6 on this side, minus 6 on this side. 24 minus 6 is 18. You're going to take 9, divide that by 9 on this side, divide 9 on this side. Y is going to equal 2. Just so happens that in the first equation they gave you what that answer was. For letters C, D, E, and F, Mr. Shane's going to do this on the board. Stick around. In our practice problems for lesson 23, let's take a look at solving two-step equations by using that reverse order of operations and the inverse operations to simplify to get that variable all by itself. In letter C, it says 8w minus 4 equals 28. Now remember, I'm thinking of this in terms of getting w by itself or eliminating those other numbers on this side of the equation because my variables and my numbers don't really mix. So we want to put those numbers on this side of the equation. Well, to do that, I use the opposite order of my operations and the inverse operations. So I have multiplication and I have subtraction. Now, order of operations in reverse order means that I would do the subtraction first, which in this case, minus 4, I'm going to add 4. If I add 4 to one side, I add 4 to the other side. This would cancel each other out, and now I have 28 plus 4 as the first step to my equation. 28 plus 4 is 32. And I'm going to rewrite this each time to show that that's step 1, step 2. Now step 2, I have 8 times w. The opposite operation here would be to divide by 8. If I do that to one side, do it to the other. These would cancel. W is going to be by itself then. 32 divided by 8, w equals 4 as my answer. Letter D. Now, this was with positive values. I worked with positives and kept it positive. With negative values, I would make sure that the operation stays with that sign, if it's appropriate. Negative 10 equals negative 2x plus 12. The reverse order of operations means I'm going to take that positive 12 and I'm going to subtract it. On this side, that'll cancel. What I do to one side, I do to the other. Here I'm using my subtraction terms with sign numbers. I got negative 10 minus 12. Same sign, sum. Add those up. 10 plus 12 is going to be 22. Keep the same sign. Rewrite the equation to show that this was step 1. This is going to be step 2. And step 2, I'm now going to multiplication or division. I've got negative 22 equals negative 2x. This is actually being multiplied here, so I'm going to divide by negative 2. That would cancel. Divide by negative 2. Notice how I kept the negative sign with it. Now I've got two negatives on this fraction. In this fraction, negative 22 divided by negative 2, two negatives is going to make a positive, and 22 divided by 2 is 11. X equals 11. Letter E. Now I have fractions. This was from example 3. 1/8 m plus 3/4 equals 7/12. Same set of rules in terms of doing in the reverse order my inverse operations. But now with fractions, I have to make sure that when I'm adding and subtracting, I've got a common denominator. In this case, I've got 1/8 multiplied by m plus 3/4, so reverse order. We're going to subtract 3/4 from this side. That would cancel. If what I do to one side, I do to the other. I'll subtract 3/4 from this side. Now, I don't have a common denominator here, but I can get the 12 to be my common denominator if I take 4 times 3 and times 3. So I would have 7/12 minus, in this case, 9/12. So we'll subtract 7 minus 9. I'm going to get negative 2/12 on this side equals, I'll bring this part of the equation down, 1/8 m. Now when I have a fraction and it's multiplied, I'm not going to divide by another fraction in order to solve that with an inverse operation. When it's a fraction, I have to remember to multiply by the reciprocal. So the reciprocal of 1/8, if I flip that over, is 8/1. If I multiply, those will cancel, and I'm left with m by itself. Now I do the same thing to the other side, and multiply by 8/1. When I'm multiplying, I can multiply numerator by numerator, denominator by denominator, and then simplify at the end, or I can try and simplify it in the midst of the equation. In this case, we've got 12 and 8, which both have multiples of 4 in it. So if I think how many 4s go into 8, this actually turns into a 2. How many 4s go into 12? This turns into a 3. Now I've got negative 2 times 2. Negative 2 times 2 is going to be negative 4. And 3 times 1 is going to be 3. And I've got my simplified expression for that variable. Now on any of these, if you want to check to make sure that you've got it correct, you take that variable and you plug it back into the original spot to evaluate. So here you would write negative 4/3, and then you'd go about multiplying and then adding to see if you actually got back to that original amount. If you got it wrong, that means you got to go back and reevaluate what that actual number was. For this letter F in our practice problems has a energy conservation scenario. The Green family conserves energy by using energy efficient light bulbs. They pay $125 for energy efficient bulbs. The family saves $7 per month on the electricity bill, and the power company gives them a rebate of $25. In about how many months will they have paid for their bulbs? A lot of times when people are making investments in terms of upgrading the materials that they have in their home, they're often influenced to try and buy something that is more efficient, therefore it will save them money. But a lot of times that more efficient technology has a larger cost up front and eventually will save them enough money to where people will say it pays for itself. As in over the course of multiple electric bills, the electric bill will be down because you use a different type of light bulb, so the money that you spent on those light bulbs will actually cancel itself out. In this case, you've got to pay $125 for these energy efficient bulbs, in which they save you $7 a month. Well, that's great. $7 less on your bill every single month from here on forward, as long as those bulbs keep working. Well, another way in which people want to do this is to offer power company will offer a rebate, which means they're going to give you money off to purchase these things because they want to obviously conserve energy and conserve our resources as well. So it's like they're giving you $25 off. It's like the family's only paying $100. So they're saying how many months will it take to make up that $100 in your overall savings. So you set this up as an equation. $125 is equal to $25 plus $7 per month. And we want to figure out how many months it'll take to make up that difference. So a two-step equation says minus 25 from both sides, minus 25 from this side. 100 equals 7 times m. You would divide by 7. 100 divided by 7 is going to be roughly about 14 months and some change. So about 14 months it'll take you to actually pay off this bill that you would have had to invest in those energy efficient light bulbs. And then moving forward after 14 months, so after a year and 2 months, you'll be saving that much money every single year or every single month for the rest of the time that you're using those same light bulbs. Pretty big incentive to be on the energy efficient train because it saves you money over the long haul, even if it takes more money to invest up front. Again, you're solving that with your two-step operations, doing the reverse order of those inverse operations to solve for that missing variable. God's blessings on your assignment.